What's the derivative?
Sec x tan x.
Well, very good, yes. Okay, so let's figure out how we'd get there. We would rewrite it as 1 over cosine x. There's two ways of doing this. I suppose you could do chain rule maybe, or you could do quotient rule. I prefer quotient rule. I'm going to use quotient rule. Okay, so quotient rule would be the bottom by the derivative of the top, which is just, well, we'll write it down, cosine x times 0, minus the, I'm using the quotient rule, vu dash, not u1, minus 1 times, what's the derivative of cosine x? Okay, all over cosine squared x, yeah? So that's gone anyway. So we get, and that's positive now, so we get sine x over cosine squared x is the derivative of sec x. We could write that a number of different ways, couldn't we? Tan x times what? Over cosine, which can be sec x. What was written in the form booklet? You had a sec no? This one?
Yeah.
Okay, this one's written in the form booklet? Yeah. But you can use this one or any version of it.
Is the derivative of constant 0 or just
Derivative of constant is 0. What is the gradient of a y is equal to 2 line? It's the gradient of 0. It's not undefined. Yeah. Okay. It's a decent, that's a good question. All right, let's do the other ones. See, can we create them? Maybe y is equal to cosec next. Cosec x, which is y of 1 over... Oh, you guys are geniuses. Let's do it. So it's going to be the same process as this. Sine x would be times by 0 minus the derivative of sine x this time is positive.
Did you just ask, can we go to the beach?
Okay, so we have this. How did they write it in the form booklet? Oh, I forgot this negative here. Negative cosec.
like cot? Isn't it?
That's a good question.
Bro, that's so obvious.
Should it be negative?
Caught backwards.
Well, this is definitely negative cosine x over sine x times by 1 over sine x. Now remember, tan is sine over cos. So cot is 1 over tan is the reciprocal, isn't it?
Why don't they just write negative cosine x times cosec x?
They could, but this is the way you're going to get it in the exam.
I don't like that we get cosec and cot.
So you have to translate that back into sine, cos, and tan?
That's
Yeah.
not how we understand it.
Okay. And you can do the same for cot. I'm not going to 1 over tan and then do that. So I have it on but I've frozen the screen. So here are the ones you get in your formula booklet. So how are we going to do an example of these? Cot is using the similar process, the derivative, not cos, I'll write it over here. If y is cot x, the derivative is minus cosine, not cosine, cosec squared x. Okay, so you can do the same process, just write cot as 1 over tan x and then maybe write as cosine over sine to do the derivative and then use the quotient rule. Okay, so confident that we'll be able to do this type of derivative. So if you're given the example like, if y is now cosec, is that just, it's not even squared, 3x, what is the derivative of that? What's the derivative of that?
Is it
Your head. Yep.
Is it not
Negative cosec 3x cos 3x. Done. Yes? No? Maybe?
No, negative 3 in front, no?
Yes, I would put the 3. Yes. So 3. So you can multiply it by 3 after I put the 3 in front.